This video is on relative velocity. In words, what is meant by the designation Vxy? That means the velocity of x with respect to y. Similarly, Vyx means the velocity of y with respect to x. The two equations that relate these to each other are the velocity of x relative to y is equal to the opposite of the velocity of y with respect to x. And similarly, the velocity of y with respect to x is equal to the opposite of the velocity of x with respect to y. So if you know one of them, if you simply change its sign, that is, change its direction, then you can find the other one. Suppose we are given the velocity vectors as shown here, and we want to write out the equation for finding the velocity of A with respect to h. So the first vector that we need to write needs to have the A first, and that's this one right here. So we're going to go the velocity of A with respect to j. That A, that's got to be first. Then the next vector that we write has to have j first. And I'll kind of show you a little bit of a visual here. And that would be this one, velocity of j with respect to w. And I like to put a little loop there connecting those j's. Now, if we did just that, we would get the velocity of a with respect to w. But that's not what we want. We want the velocity of a with respect to h. So we have to put one more in here. And again, the next vector that we put, it's the w that has to be first. The one that's given that has w first is that one right there. And what you can see is, I'm using arrows to try and help you see this. You see, we started with A, we started with A. We ended with H, we ended with H. And in between, we held hands with a friend. Birds of a feather flock together, so do pigs and swine. That's the basic method of how you want to add vectors with regard to relative velocity. Let's try this one. Let's write out the most straightforward equation for finding VHJ. Do not use any negative signs. Okay, so VHJ, the first vector that we need to write needs to have H first. Now, what's given? None of them have H first, but this one does have an H in it. So instead of WH, I'm going to write HW. That's the deal. The first letter here has to match up with the first letter of what we want. Now we're not done because we need to end with a J, so we need to add another vector. And without even thinking, we know that this vector has to start with W so that birds of a feather flock together. And what given vector has a W and a J in it? That one right there. That's the most straightforward equation for finding what we want. Now what we're going to do is we're going to modify these such that the variables are the ones that are given. So VHJ, what do we have here? We need VHW, but we don't have that. We have VWH. But the opposite of VWH is VHW. So we've got that. And then what about this? VWJ, well, we don't have that, but we have VJW. So we're going to go minus VJW. There you go. So we can get our answer based on the ones that were given. We just have to know, hey, do we keep it the same or do we have to flip the sign or whatever? Let's try one example here with a swimmer. And the swimmer is swimming relative to the Earth. So the velocity of the swimmer relative to the Earth is 1.7 meters per second north. And the current is flowing 2.1 meters per second east. So we might say that the velocity of the current with respect to the Earth is 2.1 meters per second east. And what we want is the velocity of the swimmer relative to the current. Okay, so how do we do it? Well, what we're going to do is our first vector needs to start with S, and that would have to be this one, wouldn't it? So that's going to be V, S, E. Start with S, start with S. Now we're not done yet because we have to get to a C here and we're not there. So the next vector, without even thinking, we know that it has to start with E because birds of a feather flock together. Well, what do we have here? Well, we don't have E something, we have CE. Hey, look at that. We need to end with C, we need to end with C. What does this mean? What we need is this VSE vector is good to go, as is. This vector, we need to flip. So this VSE vector, we leave it as it is, because that's right there. But this CE vector is no good. What we need is EC, like that. So when we add these vectors, we're going to go 1.8 meters per second north. Usually north is up on a map. But now we don't want 2.1 meters per second east. We need to flip that. So we need to go west. Isn't west that way on a map? 2.1 meters per second. So our resultant velocity is going to be that one right there. That's our answer. We're not going to go through this here because it's not worth our time, but hopefully you learned in an earlier physics class that these need to be Pythagorized, and we need to inverse tangentize and find an angle like that. If you do, this is what you get, I believe, to two significant figures, 2.7 meters per second at, and just look at this angle. Hopefully you can see by the picture, it's got to be greater than 45 degrees. I got 51 degrees to the west of north. Remember that the angle always has to be back at the beginning of the resultant, just like that.